Okay, let's look at number 2. It says triangle BKD was translated to create triangle MWQ. So it is important to first understand what came first, what came second. So I'm going to go ahead and label my triangles based on the instructions. It does say triangle BKD was what we started with, and it created triangle MWQ once it was translated. So what it's asking us to do now is to write a verbal description. So typically what I like to do is write a verbal description that will easily create a coordinate rule after. So how do I do that? Well, in order to do that, I need to first describe what's happening to my x coordinates, and then describe what's happening to my y coordinates. Why? Because that's typically how ordered pairs are written. So x first describes either a left or right motion, so that we do that first. And then once we've done that, we look to see if it's moving up or down. But in order to do that, you do need to first identify two corresponding points in order to do that. So I'm going to go ahead and pick, let's say, the letter B from triangle 1, which I would say corresponds to point M from triangle 2. So now that I've identified two corresponding parts, I can go ahead and describe the direction they're moving. Now some of you may ask, well, are those the only points you can choose? The answer would be no. You could have also chose Q and D, because those 2 points correspond to one another. And another option you could have used would have been W and K. You're going to find that no matter which 2 points you use, the direction of how they're moving will be the same. So I am using points M and B, keeping in mind that I am going to start with point B because that is my first triangle. So first I'm going to describe the left and right motion. I do notice it's moving 1, 2, 3 to the left. So I'm going to go ahead and write 3 to the left. And then from there I'm noticing it's moving 1, 2, 3, 4 up. So I'm going to write that down. So again, I did write it in this specific order, mainly because it is going to translate very well into a coordinate rule, which is the next question they're asking me. So if you ask me, can you switch the order? The answer is yes, but you just got to be mindful that when it comes to your coordinate rule, there is a very specific order. With a coordinate rule, you first want to always start with x comma y. You're going to draw an arrow, and you're going to describe what's happening to the x values and what's happening to the y values. So first starting with x. What's happening to all the x values? Well, they're moving 3 to the left. Well, hopefully when you think about a number line, whenever you move to the left of the origin, you realize all the numbers become negative. And typically, when I look at left and right, left will make me think of negative. So moving back here, left would be all my negative numbers, right would be all my positive numbers. So in this case, I'm going to go ahead and put, since it's 3 to the left, I'm going to put -3. Now the next thing I'm going to do is describe what's happening to the y values. So in this case, it did go 4 up, and then referring back to my directions, up typically makes me think of positive numbers, and down typically makes me think of negative numbers. Now if you're unsure, just start at the origin and ask yourself, if I went up, notice my numbers are all positive, but if I went down, all my numbers would be negative. So you can always use your coordinate plane to kind of help guide you in that direction. So because it was 4 up, I will put +4. Now taking a close look, there is a typo. It does say ADG. It should actually read BKD, translated to triangle MWQ. So if you can fix that in your notes, that would be great. Now between these two triangles, what do you notice about them? Hopefully you can notice that they're still similar because they are the same shape. But not only are they similar, they are also congruent. Because why? Not only are they the same shape, they are exactly the same size. So it's also a good idea to always keep that in mind. Are they similar? Are they congruent? Etc. Now looking at another example, it says triangle BDG was translated to create triangle NPJ. So here I'm going to first start by labeling them. BDG is my first triangle and NPJ is my second. Notice I see NP, but J does fall off, so I'm going to go ahead and just indicate there is a J out here. Now if you didn't recognize that, you could have referred back to the instructions to see, okay, I have an N, I have a P, what other letter is missing? You would figure out that it was the J. Okay, so now that I have that, you do have an option in order to find all corresponding parts by simply using patty paper and tracing it. So for example, I could trace triangle BDG like so, and literally sliding the patty paper across to see which angles are congruent to which angles. So for example, in this case, angle G is congruent to angle J. Angle B is congruent to angle N. But I know what some of you are thinking. You're probably thinking the saying, I really don't need this patty paper. I can visually see which angles are congruent to one another, and that's okay as well. So for example, some of you can say, okay, angle D. That angle is congruent to angle P. So if you can see that, that works as well. You don't need the patty paper. But if you do prefer the patty paper so that you can visually see that relationship, that's okay as well. It's totally up to you if you want to eyeball it or if you want to use patty paper to verify that. Okay, so with this part, I am going to practice doing it without a patty paper. So here, line segment BD, I would say is congruent to line segment NP. So I'm going to go ahead and write line segment NP. Next, BG, line segment BG, I would say because it's congruent to line segment NJ. Then we have line segment DG. I would say it's congruent to line segment PJ. So now that I have that, I have one more question to answer, which is to write the coordinate rule. Let's remember, we always start with x comma y, an arrow, and then we first start by describing what's happening to the x values. That is a description of either a left or right motion. So first, I need to pick two corresponding points. Remember, there are options that you can choose. Choose whichever ones you want to work with. So I'm going to pick B and N. But just a friendly reminder, could you have also used D and P? The answer is yes. Now, could you have also used G and J? Technically yes, but I don't suggest it. Why? Because J did fall off of my graph, and it is not the best choice. Always pick points that are easier for you to use. So let's go ahead and pick this one. We're going to pick B and N. Why am I starting with the letter B? Because that is part of my first triangle, so I am moving over onto N. So first, moving left or right, I'm going to decide to move to the right. 1, 2, 3, 4. Since it was 4 to the right, that's going to be a plus 4. Now that we've done that, we're going to describe what's happening to the y values. Please remember, you're either moving up or you're moving down. So in that case, from where I left off, I'm going to go up 1, 2, 3. Since it's going up, that is another plus. And we're going to write a 3. So just a friendly reminder, if you forgot, whenever you're moving left, that's negative. If you're moving right, that's positive. If you're moving up, that is positive. And if you're moving down, that is negative. So with that said, we just finished number 3. Now we're going to work on performing an actual translation. So what would that look like? Well, first let's read the instructions. It says, translate triangle SMR based on the coordinate rule given. X comma y turns into x minus 3 comma y plus 1. There should be a parentheses right here. Sorry about that. So first and foremost, I need to translate this. I am going to skip this portion for a second because I want to first decipher what this means, which they asked me to do here. So first, x minus 3. I'm going to say that means for me to move either left or right. But because it's a minus 3, I would say that's probably moving to the left. So I'm going to say 3 to the left. But now we have a y plus 1. Remember, y's indicate either going up or down. And because it's positive, that's telling me it's going to move up by how many? Just 1. So I'm going to go 1 up. So this coordinate rule is just a fancy way of letting me know we're going to move 3 units to the left and 1 unit up. Okay, so how will I do that? Well, I'm going to start with a point. So in this case, maybe the letter S. And I'm going to follow the coordinate rule, which is move 3 to the left and 1 up. So we're going to go 1, 2, 3 to the left, and where we left off, we're going to go 1 up and call that S prime. We're going to repeat this for every point. For R, we're going to go 3 to the left, 1 up, and label it R prime. Last but not least for M, 3 to the left, 1 up, and call that M prime. Now once you have those, simply connect the points, and there you have your translated figure. Now that I've done that, I'm going to go ahead and go back and write down the ordered pairs. You're going to hopefully see a pattern. So for S, the ordered pair would be 2, 8. But it turned into S prime, which happens to be -1, 9. Now for M, we have 4, 2. Which turned into M prime, which became 1, 3. For R, we have 6, 5, which turns into R prime, which happens to be 3, 6. Now, why is this coordinate rule helpful? Well, if we wanted to, we could simply use the ordered pairs to generate our S prime, M prime, or R prime, simply by using this coordinate rule. Why? Let's start with R first. You're going to find that the X values, which was originally 6, lost 3 and became a 3. You're going to see the Y value, which was originally 5, gained 1 and became a 6. Same thing here. For M, the X value lost 3 and became a 1. The Y value gained 1 and became a 3. Same thing with S. The X value lost 3, became a -1, and the Y value gained 1 and became a 9. So knowing this coordinate rule really helps you figure out the specific ordered pairs as well. But not only that, let's take a close look at our shapes. We have our original shape right here, as well as our new shape right here. You're going to find that these two shapes are indeed similar. Why? Because they are exactly the same shape. But not are they just similar, they're also congruent. Why? Because they are similar in the sense that they have the same shape, but they also have the same exact size. So we would claim that they're congruent. Now we just have one last example that might be a little tricky for some, but you're going to find it's actually pretty simple. So here it says for number 7, translate triangle SPN based off the coordinate rule given. X comma y turns into x comma y minus 3. So before I write down some ordered pairs, I think it would be important for me to first understand what this all means. So again, I kind of forgot a parentheses there. Sorry about that. I'm going to look at this. Now, it is tricky for some people. Why? Because they don't know what's happening to the X value because there's no numbers indicating that. So, since there's no number there, what number do you think could belong there? Hopefully your answer is a 0. So to help me out, I am going to rewrite it as x comma y. It's going to turn into x plus 0 and y minus 3. So once again, why did I write plus 0? To let me know it is not moving left and it's not moving right. Okay? So because it was x plus 0, nothing is happening. It's again not moving left and it's not moving right. But what about this x minus 3? Well, the x minus 3 describes either an up or down motion because that's my y-axis. So in this case, since it's -3, we know that we're moving down 3. So 3 down. So we know nothing's happening with the left and right, but we know the, in this case, triangle is going to move 3 down. So what do is start with S, move 3 down, and call it S prime. Start with P, move 3 down, call it P prime. Start with N, move 3 down, and call it N prime. All you do then is connect your points, and voila, you have your translated figure. So, what do you notice about triangle SPN versus triangle S prime, P prime, N prime? You should recognize that they're still similar because they're exactly the same shape, but they're also congruent. Why? Because they are the same shape and they are the same size. But let's take a look at the ordered pairs to see if there's anything we can notice. For S, we have 9, negative 2, which then becomes S prime, which is 9, negative 5. Notice the X value stayed the same, but the Y values were decreased by 3. So let's try the next one. For P, we have 6, 5. And for P prime, we have 6, negative 8. So once again, you're going to notice the X value stayed the same, but the Y values decreased by 3. So sorry, this is negative 5, not positive 5. And last but not least, for N, we have negative 4, negative 6, which then turns into N prime, which is negative 4, negative 9. Once again, you'll notice the X values stayed exactly the same, but the Y values did decrease. I keep forgetting my negatives, and that was a reminder that it should have decreased by 3, making it negative 9. Okay, so you'll notice I made a mistake for both of these. I forgot my negatives, so it's important to double check that.